next lecture number 5. Topic is classical normal linear regression model. Short form is CNRRM. The probability distance of disturbance UI. The probability distribution of the OLS estimator. We proceed as follows. Consider beta hat 2. Formula: beta hat 2 is equals to summation ki yi, where ki is equals to xi divided by summation xi ka square. The x's are assumed fixed and non-stochastic. Beta 2 is a linear function of xi, linear function of yi. Beta hat 2 is equals to summation ki beta 1 plus beta 2 xi plus ui. Because the ki and the betas and xi are all the fixed, beta 2 square, beta hat square is ultimately a linear regression function of the random variable of ui, which is random by assumption. It is all fixed, but beta 2 is linear function of random variable. The normality of assumption of ui. The classical normal linear regression model assumes that each ui is distributed normally with, you see, the mean value and a variance value and covariance value. Expected ui is equals to 0. Variance is expected u minus expected ui square is equals to u expected u square is equal to sigma square, and covariance is always 0. The assumptions given can be more compactly. The sample means distributed and n stand for the normal distribution. Two normally distributed variables, zero covariance or correlation, mean independence of two variables. Second point is equation means that ui, uj are not only uncorrelated but also independent distributed. You see the equations, where NID is stand for the normally and independent distribution. Sorry for sigma is up of the statement. And why the normality assumptions? First point, the variable is small and the least best random. It is known as the central limit theorem of statistics. There is a large number of independents. Second, if the number of variable is not very large and the linear function of normally distributed variable itself normally distributed. And if the number of variables is not large but the variables not strictly independent. Fourth point is the normally distributed is comparatively simple distributions. If we are dealing with the small infinites and sample size, the probability distribution of OLS. Finally, in large sample, T or F test is approximately T and F probability distribution is normally distributed. Property of ordinary least square estimator of normally assumption. First is they are unbiased, they are minimum variance, and they are the minimum variance unbiased estimator. They are the consistency and sample size increase indefinitely. Beta 1 head is normally distributed. You see the equation of mean expected beta 2 head is equals to beta 2 and the variance of beta 2 head is equals to the sigma square. And the z test is used is beta 2 head minus beta 1 divided by sigma beta 2. You see the 5 point, beta 2 is normally distributed with mean and variance, and also z value are the same of fourth point. You see the fourth diagrams and simply explained by the z distribution. It's symmetrically normally distributed. 6 point beta 1 head and beta 2 head are distributed independence of sigma square. Beta 1 and beta 2 had a minimum variance in the entire class of unbiased estimator, which it is not linear or not. We can see that the least square estimator are biased, that the minimum variance is entire class of unbiased estimator. The question of is expected yi plus beta 1 plus beta 2 had xi, and the variance of yi is equal to sigma square always. More neatly we can write yi is at mean distribution n, capital N, and beta 1 plus beta 2 xi comma sigma square. Equation 3439. You say this equation, first equation is mean and second equation is variance. It's combined. Thanks for watching this video. I hope you understand. Thank you.